Hello guys, I hope you all are fine at your place and I am fine too. So in the last class I have told that I will be explaining from the next class onwards the basics of organic chemistry. So now, do you know what would be the definition of organic chemistry? Let us see. The definition would be the chemistry of compounds containing carbon and hydrogen. Okay, so what the compounds contain both carbon and hydrogen would be called as the organic compounds. Rather, we also call them as hydrocarbons. Okay, so what does the chemistry involves? The chemistry may involve properties and nature, the synthesis and the detailed mechanism, right? And the application and use, rather we would call them in more technical terms, the activity too. Now, so we have seen the definition is called the chemistry of compounds containing carbon and hydrogen, so we call them as hydrocarbons. Now if you see what would be the classification of organic compounds, so we have classified them based on two classes, like based on two categories, based on carbon chain and based on the functional groups. So let us come to the first one, based on carbon chain. So acyclic or open chain compounds and cyclic or closed chain compounds. So it is of two types. Open chain in the sense we could see open chain in the sense, so this is an open chain hydrocarbon. If we see a cyclic one, cyclic is, we would call for example benzene. So benzene comes under cyclic or closed chain compounds. Now come to the based on functional groups. So we have many functional groups, like we have alcohols, aldehydes, ketones, carboxylic acids, etc. Okay, so now next we would see the broad classification based on the carbon. Okay, now let's see the classification of organic compounds based on the carbon chain. So it is divided into, as you have seen earlier, it is divided into two classes, like acyclic or open chain compounds and cyclic or closed chain compounds. We see the acyclic or the open chain compounds. We have seen the example would be the butane containing 4 carbons, which is an open chain compound, right? So it is divided into again two types. We have seen the let us see, it is of two types, like saturated hydrocarbons and unsaturated hydrocarbons. So saturated hydrocarbons, we can also call it as alkanes. What we can call it as? We can call it as alkanes. Alkanes example is, you can see methane, classical example, right? Now if we see unsaturated hydrocarbons, it is of two types. I mean, the examples will be two, that is alkenes and alkynes, right? Alkenes example, you can see ethene, CH2 double bond CH2, so it is ethene. If you will see the example of alkynes, it is ethyne, simple ethyne, unsubstituted ethyne, right? Now next, coming to the cyclic or closed chain compounds. So before going that, again if we could revise, the cyclic or open chain compounds is divided into two types: saturated hydrocarbons and unsaturated hydrocarbons. The examples of saturated hydrocarbons would be alkenes, and the examples of unsaturated hydrocarbons would be alkenes and alkynes. So examples of alkenes is methane, ethane, propane, etc. The naming IUPAC nomenclature will be seen in the next video, in the next part. And the example of alkenes is ethene, propene, butene, etc. Alkynes, you can see ethyne. Now Coming to the cyclic or closed chain compounds, it is divided into homocyclic and heterocyclic. So we have seen cyclic in the sense we could draw a simple cyclohexane or a benzene ring. So these are the classical examples of cyclic or closed chain compounds. So if we see, it is divided into homocyclic. Homocyclic in the sense there is no atom other than carbon and hydrogen, right? So it is also called as carbocyclic. Carbocyclic, right? So it consists of only carbon atoms. So the examples will be cyclohexane and benzene. Heterocyclic in the sense other than carbon and hydrogen, there would be nitrogen atom, oxygen atom, sulfur atom, phosphorus atom, or any etc. in the ring, in the main ring, not as a substance, in the main ring. So the example of heterocyclic ring would be your pyridine. Okay, so this is where instead of the sixth carbon, it is containing a nitrogen, which is pyridine, right? Next, we see the division of again homocyclic compounds, that is alicyclic and aromatic. So what is alicyclic? Alicyclic in the sense the saturated cyclic ring. So we could also call it as saturated cyclic ring. So the example is again the cyclohexane, right? Next, aromatic we could see the example would be your benzene ring, which is aromatic. So aromatic in the sense if a compound should be aromatic, should obey 4n+2 rule, that is also called as Hucken's rule. Okay, we'll be discussing it further in the aromatic compounds. So aromatic compounds again divided into benzenoid and non-benzenoid. So you know the benzene ring is cyclohexane ring with 3 double bonds. So that is what the benzenoid compound means. A non-benzenoid compound, which is again aromatic. It could be a 4-membered ring or 5-membered ring or a 6-membered ring. So we could take a good example is a cyclopropene ring, which is non-benzenoid, but still it is aromatic because it is obeying 4n+2 by Huckel's rule, right? Then coming to the heterocyclic rings. In heterocyclic rings, as I have told you, the example is pyridine. Again, it is also divided into both aromatic and non-aromatic. Aromatic obeying Huckel's rule. Non-aromatic example would be what we could give a 8-membered ring, right? 8-membered ring with 4 double bonds would be your heterocyclic. Sorry, you could write here oxygen or nitrogen. Okay, would be good example of non-aromatic heterocyclic compound. So we have seen all the examples. If we could revise it once again, organic compound is divided into both acyclic or open chain compounds and cyclic closed chain compounds. So in case of acyclic or open chain compounds, it is divided into 2 types: saturated hydrocarbons and unsaturated hydrocarbons. In saturated, example would be alkanes. In unsaturated, the example would be alkenes and alkynes. In case of cyclic, it is of 2 types: homocyclic and heterocyclic. In homocyclic, it is divided into 2 types: alicyclic and aromatic. In aromatic, benzenoid and non-benzenoid. In heterocyclic, it would be 2, like aromatic and non-aromatic. In the next part, I will be explaining you about the IUPAC nomenclature. How would you start? What are the components and what are the rules and regulations of it? Okay, now let us see what is IUPAC nomenclature. IUPAC nomenclature, so IUPAC full form is International Union of Pure and Applied Chemistry. So what it is a system of nomenclature. Coming to the parts of the IUPAC nomenclature, it includes prefix plus root word plus suffix. So prefix in the sense it is the first part, which again got divided into primary prefix and secondary prefix. We will learn what is primary and what is secondary prefix in the next part. Then next comes is the root word. Then next is the suffix. Again, suffix is also two kinds, that is the primary suffix and the secondary suffix. So if you see the parts of IUPAC nomenclature, it includes first prefix, then root word, then the suffix. Now let us see what is prefix. Okay, now let us see what is prefix. So we have seen the parts are like prefix plus root word plus suffix. Then coming to the prefix. Prefix, it is written before the root word. So as you have seen here, it is before the root word. So prefix is again of two types, like we have primary prefix and secondary prefix. So primary prefix is where we will write cyclo, like you have seen for carbocyclic or the homocyclic compound. So this is what a three-membered ring. So three-membered ring is prop, saturated propane, but we add here primary prefix, that is cyclo. So it is called as cyclopropane, right? And so it is only the primary prefix. It is only given for alicyclic compounds, that is the homocyclic compounds. Next, secondary prefix. So secondary prefix is given to those like the substituents. The substituents which is attached to the parent ring or the parent carbon chain. Like for halogens, like fluorine, chlorine, bromine, iodine, we write halo, like fluoro, fluoro, bromido. Then R for alkyl. Then like methyl, ethyl, we'll be seeing the root words there. Then for the keto group, we write oxo or keto as a second prefix. Then for ether group, like we write alkoxy. For nitrile group, we write cyano. For amino group, amino. Okay. Then for COOR group, that is alkoxy carbonyl. Then for COX, halocarbonyl. Then NO2, nitro. NO, nitro. CHO, that is aldehyde group, formyl. OH, hydroxy, and SO3H, sulfur group. Okay. Now the next part is the root word. So what is root word? So after prefix, the next comes is the root word. So root word indicates the number of carbon atoms which is present in the longest continuous chain. Okay. So if we could see here, if the number of carbon atom is 1, it is called as meth. If the carbon atoms are 2, it is eth. If 3, then prop. 4, bute. 5, pent. 6, hex. 7, hept. If 8, oct. If 9, non. If 10, dec. Right. Now, if it is 11, it is undec. If it is 12, it is dodec. If it is 20, it is icos. If it is 21, it is unicos. If it is 30, it is triacount. If it is 31, it is untriacount. Like 20, like if it is 10 dec, 11 undec, 20 icos, 21 unicos, 30 triacount, 31 untriacount, 40 tetracount, and it goes so on. Right? Now, if you could see an example with prefix and root word. Okay, so we have CH3, CH2, Cl, right? So how many carbons? 1, 2 carbons. So what is the root word? Root word is eth. So let us write eth. Okay. So before eth, I just forgot. So Okay, so this is the root word. You need to write a prefix, you need to write a suffix. Suffix, we will be knowing it as it is a saturated compound. The suffix will be "ane," right? And as there is no other functional group, so this is only the suffix. Now coming to the functional group, the prefix. Prefix is the substituent. It is a chloro group at the first position, right? So what you need to write? Chloro, right? So as the position, as there are only two carbons, so there is no need to specify the place. You can write chloroethane. Okay, so this is the prefix, this is the root word, and this is the suffix. So overall you could write it as chloroethane, right? You can write it as chloroethane. Now the next part is the suffix. Okay. Now coming to the next part, suffix. So as we have seen, first is prefix, then root word, then suffix. So suffix is added after the root word, right? Now what is primary suffix? So primary suffix role is to just show whether it is the carbon chain is saturated or unsaturated. That's it. If it is saturated, that is with 0 double bonds, so it is ane. If it is with you could say not one double bond, rather 1 sigma to pi bonds. Sorry, 1 sigma and 1 pi. It is the suffix is ene. Okay, if it is ine, then it is consisting 1 sigma and 2 pi, where ane is 0 pi and 1 sigma, right? So if it is suffix ane, 1 sigma 0 pi. If it is ene, 1 sigma 1 pi. If it is ine, it is 1 sigma 2 pi, right? Now secondary suffix. So secondary suffix indicates the presence of various functional groups. You could see alcohol, that is OH group, we would give the suffix is ol, like ethanol. If it is aldehyde, we give al, ethanol, not ethanol. So it's a difference. It is OL, it is AL. Don't get confused. If it is ketone, there is C double bond group, we give on, that is acetone. If it is carboxylic acid, there is COOH, we could give oic acid, that is ethanoic acid. If it is amine, NH2, we would amine, that is ethanamine. Okay, it's a pronunciation. If you see sulfur. So remaining are the examples of the secondary suffixes for the various functional groups. So in the next class, we will see the rules for nomenclature. Thank you. Please like, share and subscribe to the channel. Bye bye.